With the bobtail, we had a lot of goals. We wanted to get smaller, lighter tools. We wanted tools that held up better. We set out to reduce the installation load required to install the fastener. How much force it took to swage and compress that collar material into the grooves on the bolt. And we came up with a combination that required 30% less swage load than the conventional lock bolts. So this was a breakthrough.
When you design it for low swage, you make it to where the installation tool runs at a lower pressure, or you can have lighter installation tools. The material on the bolt is the same as a regular bolt. The threads are different. They're lock threads. Those threads have a different function than the threads do on a regular nut and bolt.
The bobtail groove is shallow. We don't need a deep groove because it doesn't have to have any tolerance fit with threads. We swage the collar in, so we have a very shallow groove, big root radius in there, and that gives us high fatigue strength. We're looking at 5 times the fatigue strength of a conventional thread.
What's really important with the fastener is really the preload or clamp. The clamping is more a function of the geometry of the collar and the metallurgy of the steel. What we do is we actually swage that collar, forces that material into the lock grooves.
When it's swaged, there's no relative motion. That becomes one part when it's installed. We have precise clamp and it's vibration resistant.
Basically, we've eliminated pintails. That's what a bobtail does.
There's a bonus effect of that. We had the ability for the installation tool to also be a removal tool. When you have the bobtail pull grooves left intact, then you can put another installation tool on there, and instead of a swage anvil, it actually has 2 cutter teeth that slide down the anvil and break the collar off, and so we have a convenient way to remove the collar.
So we had a step down small tail that we could leave on the bolt, not have to break it off during the installation process, and eliminate the shock load that gets transferred to the tool. And most tool wear issues are caused by the shock load of pin break. Once we eliminated the shock load, the wear and tear on this tool was reduced. Our customers are experiencing about a 50% reduction in ongoing maintenance costs to their tooling system.
We want to sell a complete package because at the end of the day, the customer is not just buying a fastener, he's buying an installation.